Okay, so here are the answers to those questions. State which of Newton's three laws is being referred to in each of the following. Um, so in this one, we have two people pulling. This person is pulling to the right. This person is pulling to the left. They're in opposite directions, so there's no net force. You can see the people aren't moving. They're on roller skates. They're wearing strange hats. So this must be Newton's first law. Let's move over here. Oops. Here we have objects. They have mass. This has mass of 8,000. This has mass of 1,200. This has a mass of 600. They're accelerating. So we're talking about F equals ma. There is a mass and they're accelerating. There must be an overall force. So this is Newton's second law. Not actually quite sure what is happening here. So, why is there a ruler? Maybe they're using a ruler to hit the card, and then the coin is dropping. So, here we have, in this situation, there's everything stationary. That's kind of Newton's first law. But then when they hit the card with the ruler, I think that means there's a change in direction and speed. So that's going to be Newton's second law. And this coin that was sitting here, it's also experiencing Newton's second law, but it's being pulled down by gravity. So all of them, first, second, third. Fill in the table to show the examples of forces and the interaction pairs and the mechanisms that produce it. Interaction pairs, so that's talking about Newton's third law, things that come in pairs. Drag on a leaf, the air resistance of the leaf or water, the force of the leaf falling on the air. I'm going to have to make this much bigger to be able to write in that. Come on. The force of the leaf falling on the air, force of air on leaf. I have to make this slightly thinner. Force of air on leaf. Mechanism that produces it. Oh, we missed one here. Force of the surface on the box. Force of box on surface. No, it's always going to be object A and object B, object B, object A. A, B, A, B, B, A. Force of the boat on the water. Force of water on boat. And this one. This is a mechanism that produces it. Air particles collide with the leaf. Slowing. There we go. Force of the elephant on the ground. Force of the ground on the elephant. Ground pushes up into elephant. Elephant pushes down. Squashing. It's a rubbish question. A balloon-powered car makes use of each of Newton's three laws. Describe what happens when the air in the balloon is released. Okay, so first of all, we start with the third law, because the air is pushed backwards by the car thing, the whole thing. So the air in here is pushed out the back. So therefore, the car is pushed forward by the air. That's our Newton's third law. The second law is because there is a net force forwards, car accelerates. And the second law is because it's not moving at the start. Not moving. Oh, sorry, that's the first law. And then not moving at the start. Because there's no forces. Or it could just be that when the balloon stops blowing, it stops moving. I'm not sure. Use an appropriate law to explain the following statements. The resultant force of 2000 will make a car mass accelerate 2 meters per second. That's the second law. Whoa. That is the second law. Because there is a net force which leads to an acceleration. A stationary can't remain stationary unless a force acts on it. That's Newton's first law. It's the first law. No net force. A diver exerts a force of 120 newtons on the diving board. The diving board pushes up on the diver with a force of 120 newtons. So object A exerts a force on object B. Object B exerts an equal but opposite force on object A. That's third law. Diver pushes board, board, push, diver. Calculate the size and acceleration of the car if its mass is 1000 newtons. So we need F equals ma. First of all, we've got a backwards force of 600, a forward force of 1000, so 1000 minus 600 is 400 newtons forward. So we know the forward force, we know the mass, so this goes into the little triangle like that. So 400 forward divided by 1000, 0.4 meters per second squared. Boom. What is the force needed to cause the lorry to accelerate to the right? 0.6 meters per second. That's F equals ma again. So we have 8,000 newtons multiplied by 0.6. Can't do that in my head. Is a force of 4,800 newtons. Look at the diagram below and the statements. Explain which statement is the best one to explain Newton's third law. Newton's third law is shown here because the book is not moving. No, that's stupid. Newton's third law is shown because the action force is caused by gravity and the reaction force is caused by the book pushing on the atoms in the desk. False. That's not true because they're talking about two different types of forces. Third law is shown here by the book pushing on the table and the table pushing on the book. Here we go. Object A exerts a force on... I'll change the colour of this. Ooh. Object A exerts a force on object B. Object B exerts an equal and opposite force on object A. That's why it's Newton's third law. Object A equals force object B. Object B, they must be this. There's going to be two things and they're going to be doing the same thing to each other, just in different directions. Do I need to write that out? I just explained it. No, it's the same. I just explained it. I'm so needy. Explain why the diagram does not show Newton's third law. It does not show Newton's third law because it's not object A exerting force on object B. They're two different forces and they're two different. They're both on the book. So it's not the paired force. The weight of the book is basically the Earth pulling book. The Newton's third law would be the book pulls Earth. That would be no, but it's not. It's saying weight of the book, the reaction force. So it would be the reaction force of the book on the table and the reaction force of the table on the book. So they're not, because it's different. They're different forces in different situations. How could it be applied? That is the answer. That was quicker than the last description. Hopefully that made sense. If you have any questions, you can message me. Okay, bye.